In this section, we're going to talk about integration by parts. So if we're trying to integrate something that has a product by product, we mean like some function times another function. We can use this formula, integration by parts formula. Notice it is a very long, very nasty looking formula where we have to, if this is f and this is g, we have to do f of x times g of x minus, now wait, this isn't just a little g. Notice this is a capital case G. And the capital case G, that's our notation to tell us it's the antiderivative of g of x, or you have to take the integral, minus the derivative of f times the antiderivative of g dx. Notice you still even have to find another integral. So this is a very nasty looking formula. It's not our favorite way to integrate, but it is nice for these things that we just can't do any other way. So when we still have this integral left, our goal is to pick f of x as something that's going to simplify so that our new integral that has the derivative of f will be something simpler. So like if we start with an x for f of x, if we start with an x over here, the derivative of f of x is, not 1 over x, is 1. And 1, well 1's not really difficult to integrate, that's very simple. So that's kind of our goal, is to pick f of x as something that simplifies so that in our new integral is actually something simple that we know how to take the antiderivative of. Now before you try and use this formula, because again it is long, it is nasty, you don't really have to memorize this, you just write it down and plug it in every time. But before you start, I would suggest find all 4 pieces. Find f of x and g of x, those are what you start with. Find the derivative of f and the antiderivative of g. So notice this is the antiderivative, and this is the derivative. So you do have to be careful, make sure you distinguish your f and your g, because one you take the derivative, one you take the antiderivative. Let's try it out. So let's say we want to evaluate this x times x minus 3 to the power of 7 dx. Now when we use integration by parts, f of x is usually the simplest thing there. So in this case, x is probably the simpler thing. So let's try this. Sometimes you pick it wrong and you have to switch. Let's try f of x as x and g of x equals x minus 3 to the power of 7. And now, so that's what we start with. That's our actual product in our integral. So we had an x and we had an x minus 3 to the power of 7. Now f prime of x is just going to be 1. Take the derivative of x, you get 1. Pretty simple. The harder part here is to find g of x because we need to integrate. So this is the integral of x minus 3 to the power of 7 dx. And this is actually going to be, you have to use u substitution. If you don't remember how to do this, go and check in our last video. Okay, but I'm not going to do the full thing here just because our whole work is going to get kind of messy. Let's focus on integration by parts, and I'm just going to tell you, and go ahead and trust me, that it is x minus 3 to the power of 8 with a 1/8 out here. Now, we normally always put a plus c, but this is just kind of going in our formula. We'll save our plus c for the very, very end. At the very, very end, we'll tack on a plus c and we'll be good. So we found f prime of x and capital G of x, which was the integral, and we had to use u substitution, but I just went ahead and told you what it is so that we don't get really complicated and confuse the issue. Okay, and you'll find a few problems in this section, not most of them, but a few where you do have to use u substitution as part of your integration by parts. I suggest maybe a different piece of paper or the right side of the paper to try and keep your work organized. So now, let's actually use our formula, and I'm going to write down the formula again. The integral of f of x g of x equals, and I don't have it memorized at the moment since I haven't had to use it for a few years, f of x times capital G of x, or the antiderivative, minus the integral of f prime of x times capital G of x dx. So in our case, the integral of x times x minus 3 to the power of 7 dx. is going to be f of x. This is why we write down all four parts, so we can just pull them out now. So that's going to be x times g of x, which is 1 over 8, times x minus 3 to the power of 8, minus the integral, now do f prime of x, which is 1, times capital G of x, which is 1/8 x minus 3 to the power of 8 dx. So this part is done. This part is just another integral. This integral we can do. Okay. We still have to use u substitution, but it's not that bad. So let's go ahead. I will do this u substitution for you. Let's put it off here. So when I look at this, I'm going to pick, I think u equals x minus 3. And so the derivative du over dx equals 1. So du equals 1 dx. A 1 is pretty easy to find in there. So this is really the integral. Notice that 1/8, I don't actually need that 1/8 anywhere. Let's just pull it out. So we have 1/8 times u to the power of 8, and this 1 times dx is du. So this is 1/8. Let's do u to the 9, divide by 9. And normally I would put a plus c, but when you're doing loss of integration, just wait until the very end and tack it on. And so this is u. Let's go ahead and put it back in. So this is x minus 3 to the power of 9 over 8 times 9 is 72. So that's that integral. Now let's pull everything back together. So my final answer over here is this is going to be x times x minus 3 to the power of 8 over 8 minus x minus 3 to the power of 9 over 72 plus c. Again, at the very end, go ahead and add in your plus c. So we actually had to do u substitution, then integration by parts, then u substitution again. Sorry, that was not the best problem to start with. I should have tried it first. So now let's try example 3, which actually is an easier problem to do. So we want to find the integral of x plus 1 times e to the x dx. So again, we always start by saying, okay, what's f of x, what's g of x? Because this is a product, we do have x plus 1 times e to the x, and I can't figure out any way to just get rid of it with u substitution, so I do have to use integration by parts. Now, e to the x doesn't get simpler when we take the derivative, but x plus 1, if we take the derivative, we'll just get to 1. That does get simpler, so let's choose that as our f of x. And then e to x would be g of x. So to take the derivative, we get to f prime of x, which is 1. In capital G of x, we take the integral of little g of x, which is e to the x. So now, let's take this integral. I'm not going to write the formula again because it's written up above. Let's just go follow it up here. So f of x times capital G of x. So f of x is x plus 1 times capital G of x minus the integral, now do f prime of x, which is 1, times capital G of x, which is e to the x dx. Notice this integral now is very simple. All we have to do is integrate e to the x. So we'll still have this x plus 1, e to the x, minus the integral of e to the x is e to the x. And I'll probably simplify. I could factor out an e to the x. So I'll have left x plus 1 minus 1. Those x's, those 1's cancel, so I have x times e to the x. And at the very end, go ahead and add your plus c. So that's a much simpler problem for integration by parts. So in this example 4, let's evaluate x cubed times the natural log of x dx. Okay, so f of x, in the past we've been putting like x or x plus 1 as our f of x. And I might be tempted to say f of x is x cubed. But this natural log of x, do you know how to take the antiderivative of natural log of x? No, we've never learned that formula. So instead, let's try and put the natural log of x as f of x and put x cubed as g of x. And the true reason we do this is because when you take the derivative of f of x, then you're going to get 1 over x. That seems much simpler than natural log of x, right? And capital G of x, which is the integral of x cubed dx, is just going to be x to the 4th over 4. So now we want to integrate x cubed times natural log of x dx. Let's go ahead and write our formula up above one more time. So the integral of f of x g of x dx equals f of x times capital G of x minus the integral of f prime of x times capital G of x dx. Let's plug in our pieces. So f of x is natural log of x times capital G of x is x to the 4th over 4 minus the integral of f prime of x, which is 1 over x, times capital G of x, which is x to the 4th over 4 dx. Let's just rewrite this. So x to the 4th over 4 times natural log of x minus the integral. Notice these x's will cancel. So we just have x cubed over 4 dx. And this is a very easy integral to do. I can do that one no problem. So we have x to the 4th over 4 natural log of x minus this 1/4 kind of stays there, and then it's x to the power 4 over 4 plus c. At the very end, plus c, you could rewrite that as 1 over 16, but I'm not going to rewrite it all here. Okay, and my next one, let's evaluate the integral of natural log of x. So I said we didn't have a formula for that, and that's because there actually is not an easy formula or a simple formula. We're going to actually find the formula now. Okay. Notice you don't actually see two functions there. You don't actually see a product. What we're going to do is we're going to change this. Let's rewrite this as the integral of 1 times the natural log of x dx. I can do that, right? I can always multiply by 1 without changing it. So we're actually going to set this up in an interesting way. We're going to make f of x natural log of x because, again, I still don't know how to take the integral. And I'm going to make g of x 1 because I do know how to take the integral of 1. And f prime of x is going to be 1 over x. And capital G of x is going to be the integral of 1, which is x. So now my integral of 1 times the natural log of x dx is going to be, okay, so we do little f of x, which is natural log of x, times capital G of x, which is x, minus the integral of f prime of x, which is 1 over x, times capital G of x, which is x, dx. Let's see, so this is x times the natural log of x minus the integral. Notice those x's cancel and we have just the integral of 1. That's a very simple integral. We know the integral of 1 is x. So we have x times the natural log of x minus x plus c. That is our formula for the integral of natural log of x. It is fairly complicated, which is why we haven't actually seen it before now.